Question 8, A part. Compare decision tree, random forest, and boosting, highlighting strength and weakness of each. First aspect is interpretability. In decision tree, it is very high, easy to read rules. For random forest, low ensemble of many trees makes it a black box. Boosting, low sequential tree with weights are hard to interpret. Prediction time for decision tree is very fast. For random forest, it is moderate. For boosting, it is slow, then random forest. Accuracy for decision tree, it is moderate, depends heavily on tree depth. For random forest, accuracy is high, stable and reliable. For boosting, accuracy is very high, state-of-the-art performance. Bias variance. Decision tree bias is low and variance is high. For random forest, lower variance than trees. Boosting, it is high, very low bias and controlled variance. Use cases for decision tree is rule-based decision, simple models. Random forest, it is general purpose ML, robust predictions. Boosting use cases, high performance tasks, competition, advanced analytics. Question 8, B part. Explain the architecture and components of Hadoop, HDFS, Yarn, MapReduce. Data can no longer fit in memory on one machine, so a new way of computing or devised using a group of computers to process this big data distributed. Such a group is called cluster, which makes up server farms. All of these servers have to be coordinated in the following ways: partition data, coordinate computing tasks, handle fault tolerance or recovery, and allocate capacity to process. Hadoop. Hadoop is an open source distributed processing framework that manages data processing and storage for big data applications running in clustered system. It comprised of three main components: Hadoop distributed file system, that is HDFS, a distributed file system that provides high throughput access to application data by partitioning data across many machines. YARN, framework of job scheduling and cluster resource management, task coordination. MapReduce, YARN-based system for parallel processing of large data sets on multiple machines. HDFS, each disk on a different machine in the cluster is comprised of one master node and the rest are workers or data nodes. The master node manages the overall file system by storing the directory structure and the metadata of the file. The data nodes physically store the data. Large files are broken up and distributed across multiple machines, which are also replicated across multiple machines to provide fault tolerance. MapReduce, parallel programming paradigm which allow the processing of huge amount of data by running processes on multiple machines. Defining a MapReduce job requires two stages: map and reduce. Map, operation to be performed in parallel, so small portion of data set. The output is a key value pair k, v. Reduce, operation to combine The result of map by ARN, yet another resource negotiator, coordinates tasks running on the cluster and assign new nodes in case of failure. Compromised of comprised of two subcomponents, the resource manager and the node manager. The resource manager runs on a single master node and schedules tasks across nodes. The node manager runs on all other nodes and manages tasks on the individual node.